Hi everyone, thank you for showing up. I know this is the last session before the keynote, so you must be tired. At least I am very tired. So thank you for being here with me. So before getting started, I would like to show you this. Basically, if you scan the QR code or if you just go to this link here, you will have direct access to the slides. And there are two reasons why you should be doing that. First of all, because the slides, there are a lot of hidden slides, and it's probably easier also to follow the code examples. So you will already be having access to this material. But also, that's probably the important reason why you should be at this talk. There is a prize in between. So if you access the slides, it's going to be easier for you to try to participate to this giveaway that I'm going to do. So let me go back. I see somebody was still scanning. Meanwhile, I'm going to ask a question. How many of you ever use Webpack even once? Cool. How many of you think that it's somehow, I don't know, painful, complicated, magic? Raise your hand. Perfect. So, yeah, that's what I asked myself before preparing this talk. And I actually went to Twitter to start to have a feeling of what was the common opinion about this question. And these are some of the tweets I found. Forgot how much of a pain is to setting up Webpack. How to experience the pain. Create a Webpack config that does code splitting, live reload, and source maps. Attempted to set up Webpack. Doing JavaScript the modern way is pain. This is my favorite. Webpack is magic. It can be a severe pain in the but yeah, it's magic. And then there is pain, where it's a new framework where P stands for Webpack. Then there is Øredev, of course, Webpack. Remember how much of a pain? This is actually the best one, I believe, that says you need to learn it well, or else it's just a lot of pain. So the key, I think, there is that it's not Webpack itself to be the problem, it's that the module bundling problem is actually very complicated. But in this talk, we're trying to kind of narrow it down and understand it better. And I hope that the takeaway from this talk will be that you will be able to understand much better what are the fundamental components of a module bundler, not just Webpack. And then the problem itself is going to look much easier for you. So, hello everyone. I am Luciano. The most important thing in this slide is that Super Mario there, which I like very much, and also tells you, if you didn't spot that by my accent, that I am Italian, even though I live and work in Ireland, in Dublin, for Vectra. And Vectra is a security company that does threat network detection using machine learning. It's very cool stuff, but no way related to my talk today. So if you are interested into security or machine learning, please talk to me after the talk. You can find me online, and these are some of the things that I have been doing in my spare time during the last 2-3 years that I'm very proud about, so you can check the links. Going to the important stuff, I told you you can win a prize. So if you have already the slides there, or if you just go to this link, you are going to be able to create a tweet. And as long as you don't change the hashtags, you can change everything else. But as long as you don't change the hashtags, you will be able to be extracted for winning a prize. So I'm not going to tell you what the prize is, but, you know. OK, what's the agenda for today? So first of all, we're going to explore why do we need modules? What is the actual problem there? Then we're going to explore what are the current solutions that we have in JavaScript for implementing module systems. And then we are going to get to the detail that is how a module bundler actually works. Then I'm going to try to explain Webpack in 2 minutes, which is a very ambitious goal. And then finally, if we still have a bit of time, I'm going to show you a few advanced use cases that will be very helpful for you as soon as you start to embrace module bundlers. So let's start with a real, or sort of real, application. So this is a to-do application. I guess like most of you at some point in your life implemented something like that. You can see it live, but there is nothing special about it. The reason why I want to start with this is just to show you that as many other applications, there are a number of features in this application, and we can implement most of these things using libraries or external modules. So for example, here we have to manipulate the DOM. And to do that, I'm using a library called Zepto, Because today everyone is using React, Angular, Vue.js, and I wanted to use something that looks more like jQuery, just to be unconventional. So then there are other features. This is my favorite. Basically, there is a dynamic favicon. So every time you change the number of elements, this number here will change as well. And I'm using a library to do that. Then another feature is this dynamic tooltip, and there is a library for that. This is another great feature. Every 10 elements that you complete, you will have this nice effect there. And there is another library to implement that. And then there is the local storage, 2 other libraries. And then eventually we can see, OK, this is all the code that was needed to implement this application. And you are probably already noticing something weird around here, right? And the problem there is, yeah, there are many, many scripts imported. There are exactly 7 requests only to load all the JavaScript code for this application. So this is the current scenario, but if you have been doing web development in the last 10 years, I would say, you probably know that the ideal scenario is actually this one, when you combine all the external dependencies into a single file, and then you will have all your external stuff here and your application logic in another file. But how do we do that? So this was literally me doing it manually, copy-pasting stuff from the web into a single file, which, again, is something that maybe 10, 15 years ago people would do, but now we should be doing better, right? And one way that you can do that is by creating a very simple bash script. In this case, I'm using this service called mpkg that basically allows you to access files from npm using direct URLs, and just going through a list of files and creating a single file with a bash command. Another way would be creating something more advanced. I created a little script that you can install with npm or use with npx that does the same thing, plus will do some extra stuff like minification and things like that. Nothing very special, I'm just giving you some options. But the point is that, yeah, we are doing this process here. We have 7 requests because we are trying to download 7 files, and we are trying to bring this down into 2 requests. And this could get even better if we apply minification, so JavaScript minification to the resulting files. So yeah, we have concatenation and minification of files. I think this is good. I think I'm probably done. That's all my talk. Well, if this was 10 years ago, maybe yes. But now we have to do better. We can do better. And the main difference between now and 10 years ago, I think, is that because we rely on dependencies a lot more, and dependencies are getting more and more complicated. So the main thing is that when we have to deal with dependencies, updating them should be very easy. So today, those dependencies changes all the time, and we need to update them. There are security risks, and we need to be always there and make sure we have the latest versions. Then there is another problem. Dependencies most often will have their own dependencies. That's what we call transitive dependencies. So we don't want to be tangled into this mess where, oh, I have to worry about which dependencies are needed for this dependency. I want something that will deal with that automatically. And then the other thing is the order of imports. I don't know if any of you ever used jQuery, but at the time it was very important that you imported jQuery before the jQuery plugins, and some plugins needed something else before, and sometimes you just messed up the order and nothing eventually worked. But let's see what is a dependency. So a definition from Wikipedia says that a dependency or coupling is a state in which one object uses a function of another object, which, yeah, more or less we get the idea. But what we really care about is when a dependency can be reused between projects, between organizations, shared across different people. And in that case, we used to call those dependencies modules. So my definition of modules is the bricks for structuring non-trivial applications, but also the main mechanism to enforce information hiding by keeping private all the functions and variables that are not explicitly marked to be exported. Very lengthy definition, I get that. The 2 important elements are information hiding, so hide stuff that you don't want other people to use, and then export only what is the core functionality that you want to expose to the user. So we cover why do we need modules, to share code across organization and to make easy for us to build apps that are complicated. We don't want to reinvent the wheel over and over again. Now, before moving to the next section, I want to introduce my friend IIFE, or I like to call it IFE, which basically means immediately invoked function expressions. And IFE is a very recurring pattern in Node.js or JavaScript modules. And to understand how it works, let me show you very quickly. You probably know this, but it's important to review it, how a function is defined in JavaScript. So you can define it with the arrow syntax, which is very short and simple, or with the long syntax with the function keyword. And then at some point, you will be using this function with this declaration. So you can assign for invoking the function there. Simple stuff. The point is that a function in JavaScript, by definition, creates an isolated scope. So basically, if we take this function here, what's happening there, is that secret string, which is defined inside the body of the function, is not visible outside. If we try to console log it, it's going to be undefined. And this is important in the context of IFE, because IFE allows you to wrap a function and auto-execute it, and basically allows you not just to create a scope, but also to inject some variables or some values from the outside into the inner scope. So it's a way to guarantee isolation. And it works this way. So you take any function, you apply these two parentheses there that basically defines an anonymous function in JavaScript, and then you can immediately invoke it by passing extra arguments. So this argument here is going to be used as arg1 inside the body of the function, and same for this one. And again, this is important because this is a recurring pattern when you try to implement module systems in JavaScript. So let's try now that we understand what are the two main principles and how can we get there to implement a module system. And we want our module system to provide information hiding and exported functionalities. So this is a possible implementation. We have a module here, and this module is called my module. We can immediately notice that we are using IFE there, because we have this anonymous function syntax, and we are immediately invoking it. In this case, we are not passing any parameter from the outside. Then here we have some information that maybe is needed for the module to work, but that we don't want to expose. So this information is not going to be leaked because it's living inside the scope of the function. And then there is something that instead we want to expose. There is a function called public foo, and there is an array called public bar that maybe is going to be useful to whoever is using our module. So we are just declaring this, but in order to make it really exposed, we have to return it. And when we return it, what happens is that all of this is evaluated as an expression, and the result of the expression is this return statement. So at this point, the JavaScript engine will assign this value to this variable. So basically, after all this code is executed, my module will contain some piece of value. And at this point, we can use my module. So if we try to use my module.public foo or public bar, we can access this information because it's the information we exported. Otherwise, if we try to access everything else, there is no way we can actually get the value from private foo and private bar from the outside of the module. So we guaranteed information hiding and exported functionality. Now, what is the problem there? I mean, we already implemented a module system, so what's the point of all this conversation? The problem is that this is our module system. Doesn't mean that every other company or every other library will be using this specific syntax. So we need to agree on a standard module format in order to be able to share code easily across different entities. And what do we expect from an agreed or ideal module system? So we said we have to import and export stuff, but we want to have a nice syntax for doing that. Also, we need information hiding because that's what allows us to have a nice interface and make sure that everything works even in different contexts. And then we want to be able to do other things like defining modules in separate files so that it's very easy to break down more complicated modules into separate files. And then also modules should be able to import their own modules for doing transitive dependencies or nested dependencies. Now, what is the problem? Of course, we are in JavaScript land. Do you expect just one solution? No, right? We have at least 5 solutions there, plus many others that are always emerging. And I'm sure that there are at least other 100 modules instead that I just don't know. We are going to try to explore the most common ones, but it doesn't really matter that much. It's just to give you an idea what are the trade-offs that every module system is trying to embrace. So the most common one 10 years ago, I would say, at the time of jQuery, was the global way of doing module, which basically looks very similar to what I just showed you before. So just to give you an idea, this could be some implementation of jQuery, where basically we have, the variable dollar and the variable jQuery, and we assign to that something. And then at some point in our code, we can just use this $.find. That is something that we obtained by using that module. What is the problem with this approach? So the first obvious problem is that when you have a globally exported module, you might have naming collision. And jQuery was famous for this because they were using this $, and $, is something that the browsers, or at least most of the browsers, are exposing to the user to do some stuff. So if you use jQuery without the strict mode, basically it's going to override some functionality of your browser, and you are not going to be able to access those anymore. Then the other problem is that you need to guarantee the right order of module import, because if some other module is relying on jQuery, that variable needs to be initialized already. And then also you cannot import just single parts of a module. Let's say you need, I don't know, just the find functionality of jQuery, you have to import the entire module just to be able to get that find functionality. So there is another example. This is Common.js, which is the engine used in Node.js. It's probably the most famous case, but you can use it also in different contexts. And here I'm doing a very simple example where we are defining a module called Lodash. You probably heard of a module called like that. And then the way that we export functionalities with this syntax module.exports equals something. If you ever use Node.js, you probably know that. Then the way you will require a module is by actually using this function called require and specifying the path where to get the file with that definition. Also, you can import only single functionality. For example, if you only want the function concat, you can use the structuring assignment to get only concat from inside this module. So this is a bit better because there are no naming collisions. You can rename, when you import Lodash, you can rename it to something else if you think you are going to have a collision with your current scope. Then the big thing, and the reason why I think this was very successful as a model, is that there is a huge repository of modules already available on NPM, and 99% of them implement the Common.js format. But the problem is that this mechanism works only on the server with Node.js, doesn't work natively in the browser. And also, it's built in such a way that you can only synchronously load your modules. So this doesn't fit very well the browser. There is another specification that was born to try to fill this problem of the browser import and asynchronous loading that is called AMD. I don't want to spend too much time because I think this specification is dying, but your idea, the idea I want to give you is that basically this was another attempt at defining a module by taking different trade-offs. So there is all this syntax that allows you to say, okay, this module is called jQuery, it needs other dependencies like CSOL and jQuery UI, and then there is a factory function that says, okay, we build the module this way when it's needed. And then you have another syntax to use it. You have to say, okay, where do I find the base path with all the JavaScript files? And I think it's very complicated syntax, to be honest. And that's probably one of the reasons why it wasn't so successful. So there is also another one that is called UMD that try to unify the previous three that I just showed. So some module bundlers will actually be able to give you a file in UMD format, which basically means you can load them as globals using Require.js or using the AMD syntax. But I don't want to get into too much detail. If you are interested, there are some hidden slides there. If you just scroll down, you can see more, but I'll leave you to that for later. And the new trend instead is the ECMAScript 2015 modules, also called ESM, I think is the latest name. It was even called ES6 modules at some point, but just to make it a little bit more complicated. So this module system should solve all our problems, at least that's the sales pitch. It's not really ready yet. All the browsers are started to implement it now. There might be some partial coverage. So there might be like an entire talk dedicated to this, so I don't want to spend much time, but again, there are some extra slides in case you are curious, or you can just read from these links. So the point is, okay, we need a shared module format. There are many standards. What do we do? And the common trend at the moment is that you will either use common.js, so that syntax module.exports and that require, or you will use ES 2015. But in both cases, this is not enough to make your module system work directly in the browser, and we will see why. So there will need to be some processing between your source code and what really works in the browser. And in that case, we call the processing and the result of the processing compiled bundles. So we cover also JavaScript module systems. Now let's try to understand, okay, what this processing from your source code to something that works in the browser really looks like. So the first thing I want to do before actually getting into that, I'm a bit skeptical. So I want to see, okay, what happens if I just try to run my source code directly in the browser? And this is what happens. The first line, as soon as we find some require statement, the browser just crashes, says, okay, I don't know what require is. And this is, again, because the browser doesn't understand, doesn't implement the common.js specification. So, okay, how do we define a module bundler? Again, it's something that takes modules with all their own dependencies and emits static assets that represent the same logic, but in a way that the browser understands. Another very important concept that we need to embrace in order to understand module bundlers is this idea of dependency graph. So when we have an app with dependencies, we can backtrace all the dependencies this way. For example, app will need dependency A will need dependency A2, and then we have also dependency B, and we can also have shared dependency. In this case, A and B will need this module here. And if we build this thing, we call it dependency graph. So what are the steps, the logical steps that a module bundler has to take in order to produce this bundle? The first step is to construct the dependency graph, and it is called dependency resolution. And then the second step is to take this dependency graph, so this representation of all our code, and convert it into, let's say, an executable JavaScript file. And this operation is called packing. Let's get into a slightly more realistic example. So this is a kind of a calculator app. We have different files. We have app.js, which is our entry point, so the main file that we want to execute. Then we have some logging utility, and then calculator.js, which is the core library, which is split into parser and resolver. So when we load our application, we just load the app.js, and the engine will start to load all the different files. So for example, we start from here, and app is our entry point. Then the evaluator will find this require statement, which means, okay, go to this file and start to load the source code. So we basically jump into here. And at this point, we know that this is a dependency. But as soon as we do that, we find another require, and we know there is another dependency. So we have to jump there. And we find parser.js, which thankfully doesn't require anything else. So we can go back to our calculator, and we find another require statement. So we have a resolver there. Same thing, resolver doesn't need to require anything. So we can finally go back here and require the login system. And at this point, we're done. There is nothing else we have to require. So you know how, at this point, you understand how traversing the dependency graph is something that naturally happens when we use Require.js. So during this dependency resolution, so when a module bundler is doing all this navigation, internally it is tracking all the state. And the way it does that is by building a modules map. And a modules map is nothing else than an object that is used like a dictionary, where we have basically key and values But basically, every time we discover a new node, we add a new entry there. So we will find app, calculator, parser, resolver, and then log. And just to zoom in a little bit more, the key there is the require path. And what's more interesting is that is the value in this dictionary. Every value is what I call a module factor function, which basically is some piece of logic that you can execute it to actually initialize that specific module. And basically, this is the idea. It's a function. Inside the body of the function, there is all the code from that original file that is literally squashed in there. But then all this code is wrapped, and is wrapped by this factory function. And this factory function accepts two parameters. The first one is require, there. And then we have module. And we will see better in a moment why those two things are useful. But the general idea is that the factory function is kind of flexible, so you can redefine the module and the require mechanism. So again, now we understand what is the modules map. It's this state representation of our graph of dependencies. We have to take that and convert it into some single executable JavaScript file. In reality, it doesn't have to be just one file, but in practice, most of the time, it's one file. OK, this is where the magic happens, so please bear with me. This is probably the most complicated slides, but we can do it. So this is actually the code that allows us to make this thing executable and turn all of our logic into a single file. Let's try to analyze it bit by bit. So first thing to notice is that we have an if statement. So basically, our if statement is say, evaluate everything and create a scope. But inside this scope, I want to pass this thing. And you know that this thing is our modules map. So here we have all the representation of our code. So all our source files from the original source code will be somehow copied inside all these dots, one in every specific place. And we are passing this as the main argument to our immediately invoked function. So, and we call it modules map. The next step is, OK, the first thing we have to define is our custom require function. So since all our code is inside here, inside here, inside here, and so on, we need to define a function that is able to actually execute that code in a way that makes sense for the browser. So we say, OK, this is our own require function. What do we want to require? A specific module with a given name. And then the first thing that we do is we create an empty module object that only contains the property exports, which is, again, an empty object. So basically, we're saying, I have this idea that you will have to use module.exports to push your functionalities that you want to export from the code here. At this point, we are ready to invoke the specific function. Might be this one, depending on whatever name was provided here. And it's going to match one of those names. And basically, when we invoke this function, we have to pass module and require. But now we know that module is just an empty object that will be filled by this code here. And require is the function itself. So if any of the code inside here needs to require other modules, we'll be using the same logic that we have there. And finally, when the factory function is executed, we expect that this stuff here will be filled in with functionality. And this functionality is returned back so that basically our require will export to the next level all the functionality. And the last step, sorry, I skipped all the tooltips. So the last step is that basically we just require.app, which is our entry point. So as soon as we require app, we bootstrap all this process. And it's going to load all the modules in the right order. And that's what I call the magic. I see a lot of confused faces, so I'm going to go again very quickly through that. So again, we have an if statement that passes inside the internal scope the module map. This is all our source code combined together into this representation. Then we define our custom require function that knows how to get the original source code out from this map. Given a name, it's going to be able to load let's say the name is .app, is going to be able to load the code inside here. And then we actually invoke that factory function. So if it's up, we invoke this function here, bypassing the current module object and the require statement. and then at that point, we can just return whatever is the result. I hope that was a bit clearer now. In theory, now we should know how to build a module bundler, so how to construct the dependency graph and how to turn that dependency graph into a single file that contains all the JavaScript code and can be executed in the browser. Now, my challenge for you is, do you want to build a simple module bundler yourself? I don't know if you want to do it, but if you want to do it now, you should have all the basics. And if you feel lost at any given point in time, I left there a number of resources that you can use as a guidance or as an inspiration point. So we cover most of the points. Now let's try to explain Webpack very quickly. We should have enough time. So Webpack is the state of the art of module bundler, or at least that's their own definition. So how do you install Webpack? You just do npm install Webpack and Webpack CLI. How do you use it? At some point when you install it, you will have an executable, just Webpack, and you can just say, Webpack this given JavaScript file. And you probably, if you use Webpack, you know that it's not that simple. You need to write a very lengthy configuration, but recent versions of Webpack will work if you only use JavaScript, if you don't use Babel, or if you don't use other languages. So now there is a very sensible default that will work most of the cases if you don't need an advanced configuration, which is good. So if you are curious to understand more about how Webpack actually builds that file that we saw there, so the bundle file using the modules map, you can actually do that by passing this flag, mode development, which will actually inform Webpack to not compress the resulting file and actually add a lot of comments that will help you understand what is the resulting bundle file. And it looks like this. So basically you can see that there is a Webpack require that is probably the same thing that we did with our own require. It is a little bit more complicated than our version, but you can easily read everything because it's very well commented. So that's another thing you could do if you want to understand even more how a module bundler works. So what are the four main Webpack concepts? And those are the things that are most confusing to most people. But I think now that you understand the basics, probably are going to be simpler to understand. The first thing is entry point, which in our case was the app.js file, which is basically the first file that you want to load. The first file that is going to tell you how the dependency graph looks like. Then the second concept is output, and basically it's where do you want to save the resulting file or files, depending if you are generating more files. And then this is the main concept in Webpack, and it's a bit confusing sometimes, which is loaders. And the idea of Webpack is that you can load any type of file, doesn't have to be necessarily JavaScript. It can be another language, can be TypeScript, or you can even load other files like images, like style sheets. And basically, that works as long as you have a loader that can tell how to convert that specific file into something that works natively in the browser. And then finally, we have plugins that are used to do extra things. For example, I don't know, clean up the build folder, or compress the resulting files, or maybe generate HTML pages, or do analytics over the modules you are using. So this is a realistic configuration for Webpack. And you can see all the four elements I just described. We have the entry point there, which is app.js. Then we have output, which is an object where we have to specify the destination folder and the format of the file name. And then we have this part, which is the most complicated. That is the one that specifies what are the loaders that we want to use. And basically how it works is that we have to say everything that matches .js, I want to, excluding everything that's in Node modules and Bower components, I want to use the Babel loader. So basically take the JavaScript file and process it with Babel. And you can pass extra options that are specific to the loader. For example, here we are saying, yeah, Babel, but I want to use this specific preset from Babel. And that basically will do an extra conversion, something we didn't have in our own module bundlers, that takes Babel source code and converts it into ES5 or something that works in the browser. And finally, the last section is plugins. In this case, we just want to compress all the resulting files. So I told you that everything is a module, and this is more obvious if you're using something like React, where it's very common to import like an SVG, as if it was a module, or import a CSS, and then you just use it, like here. And basically what happens is that when Webpack is finding all these resources and adding them to the dependency graph, it will use the appropriate loader to convert this SVG into something that is understood when you put it in this context. So again, Webpack can load any type of file. So you can have Babel, TypeScript, Clojure, Elm. We saw today this new language called Imba, if you were in a previous talk, which is very interesting. And they use Webpack as well if you want to integrate source code in Imba into a project written in JavaScript. But also CSS, images, and other assets. So this is another example, slightly more complicated, where we can basically chain different loaders. So if you want to process the files with different steps, you also have this option. For example, in the case of CSS, if you want to use something like, I don't know, Sass or PostCSS, you generally will have a step there. But then you need other steps, like you need to resolve all the import or URL statements to make sure you are loading all the dependencies in your CSS. And finally, you can have something like style loader, which basically will expose all the resulting CSS using a style tag in your page. But Webpack can do a lot more. You can have dev servers, you can do tree shaking, which is basically the idea that you can remove all the parts of your modules that you are not using, so we'll make smaller bundles. Then you can have dependency analytics, will tell you, okay, you are using 100 modules and you are consuming, I don't know, you are creating 2 megabytes bundle, and you probably should not do that. You can save some size here and there. And then you can create source maps and do a bunch of other things. And I want to show you just one advanced use case that I like very much. But the idea is that as soon as you start to embrace module bundlers, you realize that you can do a lot more stuff in your build process. And this is something that bothered me for a long time, and now I know Webpack helps me to solve it very easily. So this is the idea of cache busting, and if you never encountered that, I'm going to explain you very quickly what that means. So you want to load a website, example.com, and you tell your device, go there. Your device is going to fetch the HTML, and then inside the HTML you have things like, okay, you need to load this specific JavaScript in order to make the page work. And let's say that the JavaScript is called Unbundle.js, and this file can be stored in a number of different places. In this case, we have a CDN, and then we have the origin server. But you might have an arbitrary number of points in between the file that you are trying to access and the origin file. So the CDN for the first time has to go to the origin server, fetch the bundle.js, and then at that point we receive a response, we'll create a cache copy, and then it's going to be able to send it back to our device, which is going to create a cache copy as well. So everything is fine, and next time you're going to visit this website or somebody else is going to visit this website, it's going to be much faster because they will either access directly in the local copy or the one in the CDN, which is great. The problem is if someday the developer decides to update this bundle and create a new version, and there was another talk by a guy from Fastly, I don't know if he's here, that show how it's not that simple to clean up the cache. Like, it's still a very complicated problem today. So the risk is that people will still be accessing one of those 2 copies that are not updated anymore. And it's not very simple to say, okay, now you have to load the new version. So one of the solutions that people started to do, and it's very manual, is to replace in the HTML all the reference to the bundle file with this, I don't know, version 1, then at some point version 2, and version 3. That sometimes works, sometimes it doesn't, because some CDN will not consider this part here as something different that allows the CDN to consider these files different from each other. So there is another trick there that people did for a long time, which is, okay, I'm going to just change the file name. So this works with every CDN or reverse proxy. But there is still a problem that is, okay, you have to keep track of all these versions yourself. You have to remember, okay, is it enough now to do version 1 or version 2? And what if I have multiple files? And what if I have to version my images and my CSS as well? used to be a lot of pain, at least for myself. So with Webpack, you can solve it brilliantly. So you just have to define the output file name with this syntax, content hash. And basically what happens when you do that is that the files that are generated will look like this. So this is basically an hash calculated from the content of your files, which basically means that if you will never touch that file, you will never generate a new file. So only when you are changing the files, new assets will be created, and they will have a unique name that will be new in the CDN, will be new in your HTML, so there is no problem with the cache. And this is just an example, but if you want to see more advanced configuration, another use case is the Create React app. And if you just run the script, you will be able to access the Webpack config that you obtain while you are doing a React application with Create React app. So this is basically everything I got. Just to close it off, I think module bundlers are your friends, so don't be scared. At this point, it should be hopefully much simpler to understand what's happening behind the scene. And I hope that you are not thinking anymore that they are magic or they are extremely complicated or painful. I hope now the problem is a lot more easier. You don't need to do crazy configuration straight away with, I don't know, auto reloading and modules with live load and all these kind of things. You can start very small, and then you can add things as soon as you realize that you actually need a specific feature. And that will make the problem already much simpler. And then, again, if you try to build your own module bundler, even if it's simple and not like feature complete, I think you will learn a lot about JavaScript and about module bundlers. So it's probably a good exercise. One last thing, Webpack is not the only options. There are many, many other module bundlers, so make sure that you pick the one that suits your use case best. Okay, now the moment you were all waiting, I'm gonna do this extraction of, I have a little tool I wrote yesterday, so I don't guarantee it works, but it should extract 3 random tweets from the ones that you probably posted by clicking that button, and I'm gonna call the first one there, which I know is not in this room, so I'm gonna pick the second one. So, come on. Do we have this person in the room? Yeah, come to me afterwards, I'm gonna give you the prize. Okay, thank you very much. I don't know if we have time for questions, but I'm gonna be here for some time until the end of the day, so thank you.